Despite the fact that the rear axle breaks 3 times a month for Joe, the Pakistani vehicle owner still insists on repairing it. This often requires dismantling the steel plates from the previous repairs. Although the rear axle appears heavily damaged, after the master's subsequent operations, it can hold up for another 10 days. Since the owner urgently needs the rear axle, the masters have no choice but to transport it using a 3-wheeler. With the masters covering 5 kilometers in 3 minutes, the rear axle finally arrives at the shop. By this time, it has undergone reinforcing welding by 10 different masters. However, the owner didn't expect it to crack right in the center of the shell. As the bottom of the shell hasn't completely fractured, there's no need to adjust its concentricity. Just pressing and restoring the crack is sufficient. Without a hydraulic press, they plan to use a jack with an iron chain for reverse compression. Then, they'll heat the bottom joint with acetylene to anneal the steel plate. The goal is to shrink the crack as the piston rod pushes out. With continuous pressing from the masters, the cracked rear axle quickly fits back together. To prepare for the disassembly of the jack for welding, the masters first spot weld the crack to prevent displacement. To ensure the owner's peace of mind while using the rear axle on the road, meticulous masters measure the axle heads with a scraping needle. Without resorting to build-up welding, there's still room for adjustment. After confirming accuracy, they fill the crack with E7018 welding rods. Once the outer layer of the crack is completely welded, the masters consider the risk of further fractures. Therefore, changes need to be made to the additional welded steel plates on the shell. This involves altering the direction of the cracks in both the inner and outer layers. Since the outer layer was welded by the previous master, they must first cut it before marking out triangles on the inner side for stability during welding. The welding on the inner and outer sides will be completely different in this way, avoiding another fracture at the same spot next time. After cutting, knock off the central triangular steel plate, then proceed to compare the just cut steel plate. The externally welded steel plate also needs to be replaced. This way, both inner and outer steel plates are marked in place. Cut off the excess material outside the marking line. At this point, the replicated steel plate differs from the original by a crack, but it is this crack that is enough to keep the rear axle going for another 10 days. After cutting, use an angle grinder to polish the rear axle to prevent unevenness from oxyacetylene cutting, which could cause misalignment of the steel plates. Since there is still too much rust on the cut steel plates, the master must absolutely clean them up. After all, these 2 small steel plates will incur additional charges. After simple derusting, fix the triangular plate on the vise. The purpose of doing this is to grind the edges until they are completely flush with the cut surface of the rear axle. Once done, tighten it with a coconut head, and all the gaps at the edges are filled with welding rods. At this point, the original shell of the rear axle is completely transformed. The externally welded steel plate still needs to be hammered to the appropriate extent with a coconut head. There is no difference in the welding of the gaps. Next, the crack on the inner side is also welded. At least, the shell must meet the standard of no oil leakage. In order to make the surface of the shell look more beautiful, the master also needs to use an angle grinder to grind the weld scars smooth. After the treatment, compare it with the scrapped differential outer shell. The master's job is to check the fit at each position because even slight deformation can cause oil leakage. Then, use self-spray paint to cover the weld scars. So, this cracked rear axle is repaired.